Alright, so Unit 8. Let's go through the answers. Number 1 is C. 2 is A. Number 3 is C. Number 4 is A. Number 5 is B. Number 6 is C. Number 7 is C. Number 8 is B. Number 9 is C. Number 10 is E. As in elephant. It's on the screen. Okay, flipping the page. Number 11 is C. Number 12 is B. Number 13 is A. Number 14 is B. Number 15 is C. Number 16 is C. Number 17 is A. Number 18 is B. Number 19 is D. And number 20 is weird. The answer is E. Yeah, that one was really weird. And it's just the way that it, yeah. E is an elephant. I feel you. We're going to go ahead and just say that's okay. Yeah. If they put D, go ahead and give it to them because it looks weird. And it looked like the answer was D. 21 is D. 22 is A. 23 is E. 24 is C. 25 is E. 26 is A. 27 is E. 28 is C. 29 is A. And 30 is E. (31) is A. 32 is E, is an elephant. 33 is E. Y'all, my earrings are doing too much. 34 is C. 35 is D as in dog. 36 is A. Okay, turning the page. 37 is C. 38, that's a lot of questions. 38 is E. Who gave you this many questions? How evil. This is terrible. You should definitely file a complaint. 40 is E. It's somebody. I don't know who. It's on the screen. You sit up. You go up to the... Okay, which one? A. 41 is E. 42 is B. 43 is B. 44 is C. 45 is A. 46 is A. Allison, hand me that calculator for a sec. Alright. How do we do percentages again? Part over whole times 100. To get the percent, right? Of course, you're going to have a question like that on your test, naturally. Okay? So, that's how you get percent. Take part over the whole and figure out the percent. for that person, and then give it back to them. There you go. Wait. How did I do that? Wait, that don't make no sense. 19 to 28. Whew, boy. All right, so let's do this. Looking at your score, figure out what's 1, 2, 1, a 2, a 3, a 4, a 5. So if you got somewhere between 1 and 20%, then you got a 1. That means you got somewhere between 1 and 9 right. You got a 2 if you got between 21 and 40%, which is to say you got somewhere between 10 and 18 right. You got a 3 if you got between a 41 and 60%. That's between 19 and 28 right. You got a 4 if it's 61 to 80%. So that's between 29 and 37 right. 38 and above is going to be a 5. Go ahead and write it in your second column. Got a 2? What did you get last time? What did you get time before? What did you get time before? What did you get the time before?
I only did the last one. Remember that I wasn't here for you.
So now you know what you got to study, right? Right?
Oh, no, one before that I got 1.
You know how to study.
I was one question away from getting a 3.
One question. Now, I mean, is this the way the AP does it? I don't know. Yeah, this is just maybe. My understanding is that typically speaking, if you get 55% of the questions right, you probably at a 3. My understanding is you get 55 or more % of the questions right, you probably at a 3 for the AP exam. Yeah. You only did 30 questions? Why? Out of that 30, though, did you do the percentage? Do the percentage out of the 30. You got 35%? Okay. So you got to work on Unit 8. Isn't this the only practice or the review that you didn't do? Yeah. You okay? You can go to the nurse?
No.
Well, me too, girl. You and me both. All right, you guys ready to go over it? There you are. Alright, so let's look at it. Dang, is that as close as it's going to get? Can y'all see that? Alright, so first... Alright. So the first question says major anthropogenic. What does anthropogenic mean? Humans, right? There we go. Okay, anthropogenic means human caused. Sources of nitrogen pollution. Those are the two major sources. CAFOs, what does CAFO stand for? What does CAFO stand for? Concentrated animal feeding operations. Hey, headphones out. I know, selfish Johnson. Headphones out, Andrew. And both of them. I know, center of attention. Concentrated animal feeding operations, feedlots. Okay? So, commercial fertilizers have lots of ammonia. Vehicle exhaust, remember that's going to be your nitrogen oxide. Industrial pollution, again, nitrogen oxide. Let's not forget also waterlogging. Waterlogging is when we essentially just overwater our farmland. That's going to produce a lot of nitrous oxide. And nitrous oxide is that compound that's produced before diatomic nitrogen, the atmospheric nitrogen, in the nitrogen cycle. We'll review the nitrogen cycle too. And so what's left over when it's discharged into sewage or surface waters? Okay? Oh, discharge of sewage into surface waters. What does the word discharge mean? Yeah, poured into. Okay? Everybody should be writing feverishly in order to get those last few points. Okay, everybody should be writing. Okay, so discharge into sewage or discharge of sewage into surface waters. I'm sorry, guys. Questions about that? We good? We talked about sewage and how it is treated. So sewage treatment, let's go through the process. So we have the primary sewage treatment right here. So here's your poopy water from your toilet, right? The poopy water from your toilet goes through these screens, okay? And so all the solid stuff gets collected, and that solid stuff usually becomes sludge, and that should be like a sludge here, okay? Now that sludge we can actually use that sludge as fertilizer. So your poop can be used as fertilizer. Okay? And so whatever's left after that, we've got some grit. And then you get to the secondary. The secondary is kind of the clearing or the clarifying area. So we're going to use some bacteria to kind of aerate, add air to your no longer poopy water. It's more clear now. Whatever grit is left over, whatever solid material is left over, is still going to become sludge. Okay? So all that sludge gets disposed of, or it gets used as fertilizer. Okay? So this is our clarifying area. This is where the bacteria come into play. Okay? So breaking down all of the organic material from your poop. And of course clarifying the water so it's not all murky. And then the tertiary area here is where we're actually going to clean it up. We're going to use some ozone. Might use ozone. Might use some chlorine to disinfect. Okay, maybe UV to disinfect. Okay? So that's where that answer comes from for number 2, which is solid components, which are not shown in the diagram, are part of the tertiary treatment of wastewater, and the answer was disinfectant. So primary is all the raw stuff coming directly from the toilet. Secondary is the breakdown of organic material and the clarifying of the water using bacteria. Tertiary, we're going to go ahead and disinfect at that point. Ozone, chlorine, UV can be used. Now, there could be a 4th level here. Not all municipalities have this, but there could be a 4th level. And in that 4th level, we can treat it to reduce the amount of nitrogen and phosphorus so that we don't have eutrophication. Because where is this water going? Yeah, it's going back into some river or some lake or whatever. Okay, so we might want to treat it to reduce the amount of nitrogen and phosphorus so we don't have eutrophication and then the algal bloom and all that process. Okay? Some of these other answers, wet scrubbers, that's for air pollution, NOx and SOx. Filters, again, air pollution. Filters, what you put on your AC every, how often are we supposed to do that? Ms. Johnson forgets. Do you guys put your filters up for your parents? No? Oh, okay. Cool. Make my kids do it. But anywho, but you know what the filter I'm talking about is, right? The one that goes in the ceiling for your AC? Okay. And that's for air pollutants. That's for particulate matter, right? And then coagulants, that's going to be that secondary. That's a clarifier. It helps to clump all of the excess grit and salt material together. Okay. Next one. MSW stands for Municipal Solid Waste. It's called trash. Remember the trash lab we did? Yeah. So, which explains the rise of MSW generated by individuals in developing countries. Well, growing population and the mass production of consumer goods for developed countries. What do I mean by that? The poor Chinese over here making all our crap, all the stuff from Shein and Temu and all the stuff that we buy in mass bulk, okay? And so essentially, they're ending up with a lot of trash, okay? Because we're a bunch of greedy pigs. Oh, sorry, babe. I'm all up in your face. Thank you. I'll get it. Don't worry about it. I'll get it. All right. Everybody should got this. Right? Reduce, reuse, recycle. That is the order. So use less, reuse, and then at the very end, recycle. The reason why recycle is the very end, because can you recycle everything? No, you can't recycle everything. Everything's recyclable. Okay? So, start with reducing or reusing. Okay. One of the easiest ways I find to reuse, how many of us use paper towels? Right? Can you just use like the regular towel and just keep washing it? Like, right? To clean? Yeah, to clean up and stuff. Or couldn't you use like an old t-shirt? Couldn't you? Yeah, you could. Instead of constantly using paper towels. Right? Yeah. Reduce. Do you have to buy new clothes all the time? Can you just, buy fewer new clothes? Yeah, because most of our clothes nowadays are made of plastic, sadly. Yeah. A lot of polyester, which is just plastic. So we could reduce how much we could. Oh, sorry, baby. We could reduce how much we consume, and that, of course, would help this problem, right? Yeah. Okay. This one may have been kind of difficult. All right. And it was very specific. I'm not going to lie. This is very specific. Compost experts recommend that carbon nitrogen level of 30-1. Okay, so 30 dark to 1 light, essentially, in order to optimize decomposition during composting. That's just something you got to remember, 30-1. What is composting? Okay, so what we're going to do is we're going to use soil, worms, bacteria in one big bin. It could be a trash bin. Close it up. And whatever food material that we would normally throw away, we would put into that compost bin. And we would just kind of rotate that soil every now and then to try to aerate it. And what does that do? That keeps us from throwing food stuff away in the landfill. We know that food is going to decompose anaerobically and produce methane. Okay? So if we compost, that reduces the amount of anaerobic respiration in the landfill. Okay? Because, like I said, the decomposing organic material in the landfills produce CH4. We know that CH4 is a what? Greenhouse gas. Okay? So if we, does anybody in here compost? I guess you have. Yeah, you know, it can be kind of difficult because, you know, if you've got any, like I've got critters all over my house, not over in my house, but around my house. That can be kind of difficult because you can imagine those critters will get into your compost bin, right? So that can make it difficult. And then sometimes compost bins do smell bad. So that's, yeah, they can smell bad. So that's kind of the negative attributes to composting. But do you guys remember the documentary that you watched, Biggest Little Farm? Remember they had the composting, they had the worm poop? You don't remember the big worm facility they bought? Or they built, actually. Yeah, and then, you know, they would spray it and it was stinky and all that. And they used the compost for their plants. Yeah. All right. So in a river ecosystem, dissolved oxygen concentrations drop quickly downstream from a point source input. Remember when I told you what a point source was? It's when you can point at the source, right? Okay. All right. So the effect is due to increasing bacterial activity as organic matter decays. Okay, here's what happens. That increase in nitrogen and phosphorus from organic matter is going to increase the amount of aerobic bacteria. Because they're aerobic, air means what? It needs what? Oxygen. So the more aerobic bacteria there is, the more oxygen is going to get used up in the water, so the less dissolved oxygen there'll be. Question?
Why is it down? What is that mean?
Oh. It's right here. Aerobic bacteria absorbs more dissolved oxygen. It's DO. I'm sorry, guys. There's like a delay. I'm not sure what that's about, but there's a little bit of a delay. The camera is really struggling. So remember that was that part in eutrophication that we talked about when there was an increase in nutrients in water, and the nutrients caused the increase of algae in the water, and the algae died real quick. Then the bacteria start to eat the dead algae, and that bacteria is going to absorb more of the dissolved oxygen because there's going to be more bacteria. Okay, and I drew your little picture right here. So here's upstream, here's downstream. Downstream is kind of where the water's flowing. So let's say this is some poop right here. Poop happens right here. You get an algae bloom right here. And then about right here, you've got some bacteria that are going to eat the dead algae because algae doesn't live very long. And that's going to decrease the amount of dissolved oxygen. And it's going to increase biological oxygen demand. Remember, biological oxygen demand is just the amount of bacteria that is using up the dissolved oxygen. So that decomposing, or that bacteria that decomposes the dead algae, they're increasing. All right. Bacteria are beneficial in the wastewater treatment process because They break down the organic matter. That is their purpose. Great. Hold on.